Hey guys, welcome back to the channel. My name's Jack, I'm a second year medical student at St George's University London. In this video we're going to be going over some quantitative reasoning questions, and I'm going to be showing you exactly how I answer the questions, and hopefully this is going to help you boost your quantitative reasoning score in the UCAT. For the quantitative reasoning section you will have 36 questions in 25 minutes, so you have about 40 seconds to answer each question. It's relatively time intensive, but it all depends on how you are with your mental arithmetic and just numbers in general. I'd say give yourself around 30 seconds for each question, and if it's taking you much longer than that, just to flag it and move on to the next question and come back to it later. There can be some kind of trick questions in the quantitative reasoning section, so I'd recommend still reading the question really carefully. You don't need to know too much prior knowledge, and you don't need to memorize many equations for the quantitative reasoning section, but I'm going to give you a couple of bits of information now just to refresh your memory, because this is the type of stuff that you will need to know. You'll need to know how to calculate a mean, an average, which is pretty simple, but if you don't know, you just need to add all of the numbers together and then divide by the number of numbers that you have. For the mode, it's just the number that occurs the most frequently, and for the median, you calculate this by putting all of the numbers in ascending order, so smallest to largest, and it's the number that's directly in the middle. So if you had 5 numbers, you put them all in ascending order, it would be the number that's right in the middle of all of those. You also have to be quite comfortable with percentages and decimals. I'll be going over an example of that in the video. And you also have to be quite comfortable with converting things. So for example, converting things from meters to centimeters, centimeters to meters, kilometers to miles. I'll put a full list of stuff on the screen now that you'll need to know, but I'll be going through some of the examples in the video. As I say, for all of the sections, the biggest thing you can do for the quantitative reasoning section is to practice. The more practice you do, the better you'll get and the faster you'll get. Recommend around 6 weeks in total for your preparation for the UCAT. Don't worry if at the start you're really bad and you really struggle with these kind of questions. You'll get better as you go. So let's get right into some questions now. Okay, we're going to do a percentage question now. This question gives us a table with 3 countries. Showing us the amount of hectares of cherry and plum trees in each country, and the question is asking us by what percentage area covered by organic plum trees in the 3 countries combined greater than the area of covered by organic cherry trees in the 3 countries combined. So it's saying about all of the numbers combined, so we need to add all of these up together. So let's do the cherry trees first. 2,907 plus 574 plus 863 is 4,344. What I recommend you do is to write this number down on your piece of paper. Cherry trees 4,344. Now we're going to do the same for plum. 759 plus 2,471 plus 1,195 gives us 4,425. So plum, 4,425. Now the key with any percentage questions is to find the difference between the totals first. To do that, we do 4,425 minus 4,344. That's 81. And then we're going to divide that difference by the smaller number, 4,344, and that will give us the answer as the percentage as a decimal. To convert it to a percentage, we times it by 100. That will give us the answer as a percentage. So that's 1.86464%. Now, if we look at the answers here, the answer is not actually listed. So if you're thinking, well, what do we do now? This must be wrong. No. If you think this is 1.8% and one of the answers is 1.9%, it's assuming that we have to round this up. So it only wants the answer to 1 decimal place. And if you have a situation like this, we must look at the other decimal places. So the next one past the 8 is a 6. If it's 5, 6, 7, 8 or 9, you must round up. So if this number here is above 5, is it 5 or above, then this number here goes up by 1, basically. So if this was a 4, 3, 2 or 1, the answer would be 1.8%. Since it's 6, we must round this up to 9 instead of an 8, so it would be 1.9%. Let's see the answer. There we go, that's correct. Okay, so this is going to be the last percentage question. Right here we have a question about buying leaflets, and it's giving you information about the cost of buying one leaflet from a printing company, and they're telling you that VAT is charged at 20% of the total order. So here we have a table. It breaks down all the different kinds of leaflets that you can buy and how the cost changes depending on how many you order. It's saying that 100p equals £1, and the question says Gina buys 450 single-sided colour leaflets. The total cost to the nearest pound, including VAT, is what? So let's have a look. She's buying single-sided colour leaflets. So it's this column right here. And then we have the number ordered. It's 450, so it'll be within this bracket, 200 to 599. So we can see that each one is going to cost us 60p. So let's do the calculation. Right, so there's two ways to do this. If you just did 60 for 60p times by 450, that would give you 27,000. This would give you the answer in pennies. So if we divide by 100, you would then get the answer in pounds to 270. What I like to do is I already converted to pounds in the beginning. If 100p equals £1, then 60p is 0.6 pounds. So do 0.6 times by 450, we get the answer of 270. But that's not where the question ends. The question is saying that we have to include VAT, and that VAT is charged at 20% of the total order. So this is basically doing a percentage increase by 20%. To do that, all we have to do is times this number by 1.20, so that's 20%, basically saying 1, so timesing this by 1, and then by 20%. So here we go, the answer would be £324. That's how much it's going to cost Gina. Let's double check the answer. There we go, exactly, the answer is D. We're then told that Stefan bought 300 double-sided black and white leaflets and 100 single-sided colour leaflets. What percentage, correct to one decimal place, of the total cost, including VAT, did he spend on colour leaflets? Okay, so this one is going to take us a little bit longer. We're going to have to write some stuff down as well. So he bought 300 double-sided black. So double-sided black, let's go to 300, so that's 55p. So 0.55 times by 300, 165, times that by 1.2 to include VAT, so 198. And that's for black, and so that's for double-sided black and white. And then same for coloured leaflets, 100 single-sided colour leaflets. So if we go here, we look for 100 single-sided at 80p each. So 0.8 times by 100 times by 1.2 was 96. So 96 for the single-sided colour. What percentage of the total cost did he spend on the colour leaflets? So to figure this out, we need to find out the total. So 96 plus 198 is 294. And then it's just a simple what percentage of 96 is out of 294. So to do that, we just do 96 divided by 294. 96 divided by 294 times 100 is 32.65%. So remember, because this number here, the number that we're not including, because it's one decimal place, is a 5, then we must round this 6 up to a 7, so it becomes 32.7%. That's the answer. There we go. Okay, here we have the kind of interpreting from a graph question. There'll always be some graphs and tables, something that you've got to interpret data from. I thought this one's quite good because, well, it's talking about gas and electric bills, which are soaring at the moment. So let's go over this one. Which year did gas prices change the most? It's going to be the biggest number for the for a grey bar. That's what I'm looking for. So I'm going to say it is year 5 because that's where you have 4. That's the biggest number out of all of these in terms of percentage change. So I'm going to go with 4. Sorry, 5. Yep, 4% change. And they're probably going to get a bit harder now. In which year was the greatest difference between the change in gas and electricity price? Okay, so we're looking for the biggest difference in terms of these two numbers, right? So here, this is a difference of 4, 6 minus 2. Here, 4, 3, that would be a difference of 1. 5 to minus 3, well, you've got to first minus 5, so to get a 0, and then another 3, that's a difference of 8. And here, that's a difference of 3, because you go from 1 to 0 to minus 1. And then here, year 1, we have a difference of 1, so overall, here the answer would be year 3 because there's a difference of 8, which is the biggest difference. Yep. Okay. At the beginning of year 1, an annual gas bill was £320. Assuming gas usage remains the same, what is the bill likely to be at the end of year 2? Okay, so this is right here, it's saying the beginning of year 1, which means we have to include this change here. If it's at the end of year 1, then we wouldn't, but because it's saying the beginning of year 1, we have to take into account this gas increase of 2%. So let's get the calculator out. So we have £320 and we have to increase it by 2%. Increasing by 2% is just timesing by 1.02. That's 326.4. And then we need to decrease this number by 1%. How we do that is we times it by 0.99. Because this is like saying what's 99% of this, because we're getting rid of 1%. And that's £323 and 14 pence. Remember, we round to 2 decimal places, so because this number at the end here is higher than a 4, we round this number up by 1. Okay, so the answer should be A. Yeah, here we go, there we go. Okay, this question, in which year did the cost of an average combined gas and electricity bill increase the most? Okay, so you might be tempted for this one to just say, okay, well, this is just the biggest percentage increase of both of them. So 2 plus 6 is 8, 4 plus 3 is 7, you know, so it's got to be year 4. However, they are trying to trick you again. This is where you really need to look at the question carefully. It's saying, which year did the cost of an average combined gas and electricity bill increase the most? It's not asking you which year did the percentage increase the most. It's asking you like which year had the biggest sort of average bill. But to know that, we would need to know about people's usage. This is basically saying, you know, another way to think of this is like saying it's the percentage increase per unit of electricity or gas. You know, like let's say turning your light on for an hour costs £10 in year 1, £12 in year 2, you know, the £15 in year 3, something like that. It's not actually talking about the usage at all. So the answer here is actually can't tell because we're not given that information. This is why you have to read the question so carefully. Okay, this question's kind of got a bit of everything in there, so let's go through it. We've got a table here with a bunch of different populations of some towns and different years. The question here is that in 1951, the total population of Enich was 16.8 million people, of which 49% lived in towns. Approximately, how many of Enich's population lived in towns in 1951? All we need to do is a simple percentage of the total, and this is why you need to be really familiar with decimals and percentages for the UCAT. So to do this, we do 0.49 times by 16.8 million. You don't have to actually write out the full number, which would be 16.8 and then 4 zeros. You can just do 16.8 and then that will give you the answer in millions. This is 8.232 million. So 8.23. Remember, we don't round up because this is a 2. The last one is a 2. If it was a 5 or above, we'd round up to 0.24 or 8.24, sorry. So the answer should be 8.23. There we go. Let's go to the next one. Okay, what is the mean of the number of people living in all 5 towns in 1901? Okay, we can do this now. Just need to add them all up first. So if you want to save time, you don't have to put the 3 zeros, the 1,000 at the end. You can just do 174 plus 123 plus 98 plus 202 plus 238, and then you add them all at the end. So 835,000. And then we're going to divide by 5 because there's 5 towns. Then we get the answer of 167,000. So that should be A. Yep. Cool. Really easy one. Mean is just the average. That's how you calculate an average. In 2001, which town's population gives the median figure for the 5 towns? So, in case you don't know, median, how you work that out is you first have to put all of the numbers in order. So we would do the smallest one first, which is Pobble, then Hellsworth, then Waston, then Ellsbraith, and then Waring. And that's the ascending order of it. So the number in the middle would be the median, which is the middle amount. It separates the lowest ones from the biggest ones. So the middle, so we have 5 here. So the one in the middle would be number 3. So then number 3 we can see here is Waston. Yeah, exactly. If you're not good at kind of keeping track of this in your head, maybe just write down the order on your piece of paper so that you don't forget. Okay, what is the mode for the size of the populations of the 5 towns in the period 1851 to 1951? Okay, so right here we're going to have to just disregard these 2 columns. The question doesn't ask about it, so we're just not even going to look at it. Then we're going to see if we can see a number that reoccurs. So right here we have 82,000, 82,000. See, that's twice. We have 174,000. Oh, we have 174,000 again. Let's see if we can find it again. Yeah, 174. Now we need to look for other numbers, see if they occur more than once. 98,000, no. 202,000, no. 238, yeah, we got 238,000 here, 238,000 here, and that's it. 174, we've done that one. 135, no. 376, no. 303, no. 445, just once. 329. So you can see, I think the number that we've found that occurs the most is 174,000, so that must be the answer. There we go, it appears the most, D. Okay, we have a question here about garden rollers. We're told here a bunch of different roller lengths and diameters, and the question is that an Agri R roller was used to roll a garden length of 20.02 meters in 105 revolutions. Assuming that the roller made only complete revolutions, what is the width of the garden? Okay, so let's put this stuff on the screen. So I recommend that you write this out. So you have the length equals 20.02 meters. We're trying to find out what the width is. And we are given this roller. So we are told that this roller can roll a garden in 105 revolutions, and that we're assuming that this roller made only complete revolutions, we are able to find out what the width is. So basically told that if we can find out the area of this roller, we can find out the area of the garden, because this roller can fit 105 times in this garden. So we times this by 105, we can get the area of the garden. And then, once we know the area of the garden, we can find out the width, because of the equation area equals width times by length. So let's go through it step by step. We're told here that we can find out the area of the cylinder with the following equation, 2 pi RH, where pi equals 22 divided by 7. So let's do that now. Do 22 divided by 7 to get us pi. And then we can do this equation. So 2 pi RH, so let's break it down. 2 pi, so times this by 2. And then times by the radius. We're not given the radius, but we're given the diameter. Now the diameter, if we can do this from a circle, if we get a circle here, diameter is this distance here. The radius is just this distance here, it's half of the diameter. So half of 46 is 23. So times this by 23. And then we're given the length of the roller, which is the same as the height. If you imagine a roller, if the roller is standing up, we call this the height. If it's on its side, we call it the length, basically. So length and the height, the same thing. So if we times this by 91, we should get the area, which is 13,155.999. So all we need to do now is times this by 105, and then we'll get the area of the garden. So do this times by 105, get the answer, or the area of the garden, as 1,381,379.8. That is our figure for the garden. Okay, so now all we have to do is rearrange this equation to give us the width. So width equals area over length. So let's do that. Now, we have the length as 20.02 meters. This area we've got here is centimeters squared, because all of these figures that we've used are in centimeters. So we need to convert the length from meters to centimeters. Do that by timesing it by 100. If you can do that in your head, that's great. It's 2002 centimeters. If not, and you're thinking, oh no, I don't want to lose this number, you can use the memory store function here to store this number, then clear it, and then we do our 20.02 times by 100 give us 2002, and then you times that by the number we had earlier. The way to get that back, if you stored it, is you do MRC here, and that brings the number back. And then now if we divide that by 2002, we get the answer of 689.9999 centimeters. Now, as you can see, the width of the garden here, the answers are in meters, so we need to then convert this back to meters. So if we divide that by 100, we can get it back to meters with 6.899999. Round that up, 6.9. So the answer would be 6.9 meters. There we go. See, it's quite a complicated question. It takes quite a while. So if you're struggling for time, as I said, come back to this one at the end. A lot of conversions in there. We're having to work out a lot of stuff like the radius, like the length is equal to the height, the fact that you have to find out the area first. You know, there's a lot going on here, but it can be done, and that's how you do it. Okay, so the next question we have is a garden rolling services company charges 69p per square meter to roll a garden. If the company uses garden roller R to roll a garden in 70 complete revolutions, how much did it charge the customer for its rolling services? Okay, so let's get the calculator out, and just like the last one, we have to find out the area of the roller. So let's do 22 divided by 7. We times that by 2 because it's 2 pi, then times that by the radius, so 42 divided by 2 is 21, and that's times that by 50. That gives us 6,599.9995. So let's just round that up to 6,600. So 6,600. And we're told that that can complete 70 revolutions inside the garden. So to find out the area of the garden, we times that by 70. That gives us 462,000. That's the answer. Since this is centimeters squared, and we need to get to meters squared, normally divide by 100, but now we have to do 100 times 100, which is 10,000. So we divide this by 10,000 to get it to meters squared, which is 46.2 meters squared. So normally you divide something, let's say you have 100 centimeters, you need to convert that to meters. You would just divide by 100, and then that would get you 1 meter. But in this case, it's 100, let's say for an example, 100 centimeters squared. You would need to divide that by 100 squared, right? Because you're cancelling these two, because this has to equal out. And then 100 squared is 100 times 100, which is 10,000, which would give you 0.01 meters squared, right? So in this situation, we have to divide by 10,000 to get to meters squared. And let's carry on with the question now. The garden roller service company charges 69p per square meter, so let's times this by 69p. That gives you £31.87, and then this 8 here at the end, so we have to round up. So £31 and then 88p should be the answer. Okay, so there we go. Okay, that's all the questions that I'm going to be doing in this video. I hope that was helpful. There's a lot of maths to do here, a lot of different things that they try and do to trick you up, and a lot of multi-step calculations. Can be quite tricky, but the more you do it, the easier it will get. If you've got any questions, please leave them down in the comments. If you like this video and it's helpful for you, please like the video. And if you want to see more videos like this, then please subscribe. The next section I'm going to be doing will be the abstract reasoning section. So stay tuned for that, and see you in the next one.